Okay, in this video what I'd like to do is deal with what are called air masses, and then I think what I'll probably do is some separate videos for fronts. Maybe a short video for each type of front, or maybe combine them all into one larger video. I'm not sure yet. I'll decide later. But the lab that you've been working on, the Weather Patterns Lab, has some questions in there about air masses and fronts. And some of you emailed me or were asking me about this in person. I don't remember which, but your questions largely stem from the fact that we just haven't gotten to it yet. And that's why I asked you to kind of wait on the Weather Patterns Lab, because as you get towards the end of that lab, it really starts pulling all of these different concepts together. And, the earlier concepts like the isotherm maps, isobar maps are pretty straightforward. But then when we start getting into air masses and fronts, you got to start pulling more ideas together. So anyway, let's just jump into it. Okay, so we're starting out with air masses, and then we'll do fronts later. So when we're talking about an air mass, essentially what we mean is we're talking about a large body of air, a large amount of air that has similar characteristics as far as temperature goes, moisture, and pressure. Now, these air masses form or take on the characteristics of their source region. And a source region would be a geographic area where an air mass develops. So, for example, air that forms or sits, I say forms, it's not like the air gets created, but the air stagnates or sits over an area for a period of time, and it's going to take on the characteristics of that climate. So if we have air sitting over the desert for a while, that air is going to become warm and dry. If we have air sitting over the poles, it's going to become very cold. Air at the equator is going to become very warm and humid. So that's what we mean by source region. It's basically the climate of where the air has been sitting for a while. And the air will eventually kind of take on the properties of the climate, the source region. Okay, so an air mass that forms over the water is always going to be much more humid than an air mass that forms over, say, the desert. Okay, so the source region determines the type of air mass. So there's 5 different air masses that we're going to look at, or designations, I guess we'll say, for air masses. The first one would be a tropical air mass. Now, you've got to be a little careful here. In this case, the word tropical, all it simply means is that the air has a high temperature. Usually when we think of tropical, we think of like rainforests, but that's not the case here. All right, not rainforest. It's not humid necessarily. It could be. The tropical designation just means that it's hot or high temperature air, but it's not giving us any indication at all about the humidity. It could be very hot, dry air, like a desert environment, or maybe it is hot, humid air that we would think of as tropical. But just be careful with this word tropical, because it doesn't necessarily mean hot and humid. It just means hot. We have polar air. And polar air originates over polar latitudes, places like Canada, places that are associated with low temperatures. Canada would be a good example of a place that has polar air. As we get closer to the poles, we might have some Arctic air. And in fact, right now, we have Arctic air in our area. Air from the Arctic has moved down into our region, and that's why we're looking at a potential record-breaking low tonight in the teens. So we had air from the poles, from above the Arctic Circle, moved down into our area and brought that very cold temperature with it. So Arctic air is typically associated with not only being very cold, but also being very dry as well. Remember, the amount of humidity or moisture the air can hold is dependent on temperature. And when we have very cold air coming out of the Arctic, because it's so cold, it's typically very dry. Okay, so we've got equatorial air. Oh, sorry, I wrote the wrong thing. That doesn't make sense. Equatorial over land masses. We're talking about continental. Sorry. If we're talking about air that forms over the land, that's a continental air mass. So air that develops over, say, the Midwest, maybe like the Dakotas or Iowa, a place like that, we would call that continental air. And continental air is associated with being very dry. It's not near a water source like the ocean, so it would be dry. And then lastly, we have maritime air. Maritime essentially means ocean. This is air that formed over the water. Typically ocean could be a large body of water like the Great Lakes, and it's typically moist air, and we're dealing with moist air. So these are the basic terms that we could use to describe air masses. Now we can combine these together to describe specific air masses or types of air. And there are symbols for this. The symbols are in your reference table. But if we have CP air, and typically the way it always is the first letter of the symbol is lowercase, and then the second symbol is upper. I'm not sure why that is. It's just kind of convention. It's just sort of how it's done. But in this case, now we have a continental polar air mass. And what this means is that we have air that formed over a continent in a polar climate. And remember, pole doesn't necessarily mean the poles. It just means a colder climate. So a very typical continental polar air mass would be out of central Canada, or maybe the north central United States, the Dakotas, Minnesota, places like that. So this would be a continental polar air mass, which means that it's going to be cold and dry air. We often see what's called a maritime tropical air mass, and in this case, remember, maritime means ocean, tropical means warm. So now we're looking at a warm and humid air mass. Okay, we could have a CT type air mass. And, I'm going to write on the sides here where we would usually find these. For a continental polar, think places like Canada, central Canada. The coasts are different, but places like central Canada, you would see your continental polar air masses. Maritime tropical, a place like the Gulf of Mexico, would be a great example of where we would find maritime tropical air masses. Okay, then we have continental tropical. With continental tropical air, this is going to be very hot, dry air, and you might find this in the Southwest. Places like maybe Arizona. Desert environments is where you would find continental tropical. And then lastly, out of the ones we're looking at, there's maritime polar. And a maritime polar air mass you would find in cold water. So it's cold air that's also humid. You would see this in like the North Atlantic. Cold ocean water. Okay, there might be icebergs in that water. Okay, cold ocean water, you would get maritime polar air. Now this is important because it really determines what kind of fronts we get and where those fronts occur. We're not there yet, but again, we're starting to get to the point now where we've gone through quite a bit of the foundation work and can start working on actually tying all of these concepts together to really make forecasts and predictions about the weather. Now, let's do a little bit more with air masses, and then we'll stop and we'll deal with fronts. So here's a map of North America. Focus on it a little bit. And we can label where we would find different types of air. So for example, in the center of the continent, north center, northern United States, central Canada, I would expect to see here continental polar air. It's cold, it's very dry air, and this air might be hundreds of miles across, and it's just sitting there. But once it starts to move, like let's say it moves towards us, then it's going to bring the properties of northern Canada and northern United States with it. And this is why sometimes we get really cold, dry air. In other locations, try to press that down a little bit, maybe we get maritime tropical air, like the Gulf of Mexico, warm, humid air. The South Atlantic, over here, near the Caribbean, near Bermuda, maritime tropical. But if we go further north, up by like Nova Scotia, Prince Edward Island, New Brunswick, and Canada, now we're dealing with maritime polar, so cold, humid air. Down over Mexico and the American Southwest, we would have continental tropical air, hot, dry air. Here in the South Pacific, we would have maritime tropical. And then in the northern Pacific, up by like Washington, Oregon, and up into the Gulf of Alaska, we'd be dealing with maritime polar. Now, that's the typical setup, but remember these air masses move around. They get blown around by the jet stream and winds in the upper levels of the atmosphere. And that's going to cause these air masses to shift around. And that's really what causes changes in our weather. So in some situations, when the airflow for us is from the south, we're going to get maritime tropical air into our region, and it's going to be very warm and humid. When we have cold continental polar air move into our region, we have cold, dry air. Right now we have that continental Arctic air coming down from all the way up here, making it very cold for April. It's not horribly cold, but for the beginning of April, this is unusual. We would never see continental tropical air in New York. That's desert air and really sticks to the southwest. So we would never see this in New York. All right, not in New York State. We're not going to get a continental tropical air mass where we live, but in places like Mexico, Arizona, Utah, Nevada, certainly continental tropical. The ones that affect us most where we live here are the continental polar and maritime tropical. These are the ones that impact New York State most. We do get other air masses from time to time, but the continental polar and maritime tropical are the ones that affect us most often. And these are the ones that you're being asked to identify in the Weather Patterns lab. And in that lab, they're asking you to look at your weather map, and based on temperature and maybe humidity characteristics, try to label where continental polar, maritime tropical air would be, just using these symbols, kind of like we did. So look at the map, try to figure out where continental polar air would be, try to figure out where your maritime tropical air would be, and try to label it on the map. That's what it's asking you to do. All right, so we'll stop here and we'll pick up with fronts.